And right on to the next one. So when they die, stars 3 times the mass of the sun become what? Okay, so what happens when stars die is, for smaller stars like our sun, these outer layers basically just shed off, like you can see in these pictures. They look quite beautiful. And what remains in the center is basically the core of the star called the white dwarf. The colorful pictures that you see surrounding the white dwarfs in this picture are called the planetary nebulae, not to be confused with the nebulae given in one of the options. So what happens when massive stars die is they go supernova, and the remnant is either a neutron star or a black hole. But the requirement for these supernovae is the core itself has to be somewhere around 1.5 times the mass of the sun to turn into a neutron star. This is something called the Chandrasekhar limit, and while we don't have such a nice theoretical limit for the formation of black holes, it's estimated that it's somewhere around 3 solar masses. But that has to be the mass of the core, and so to form a neutron star itself, the star has to have a mass of at least 5 to 8 times the mass of the sun. And so I'm not sure whether this is intentional, but the correct answer is white dwarfs, but I have a feeling that they'll say black holes in the answer key. Let's just check. So as we suspected, the answer given here is C. And it says the biggest star will become black holes when they die, which is true, but 3 solar mass stars are not really very big stars. I think we won up the quiz. Okay, let's just move on to the next one. Why is it called the Milky Way? So, like I explained in the beginning of the video, it is called Milky because it looks milky. The answer is C. Okay, what is Sagittarius A? So like we discussed in the beginning of the video, the sky is divided into multiple regions called constellations. And when we see something interesting in that constellation, for example a star or an irregular object, we name it after the constellation, for example Sagittarius A over here. So as you might expect, this object is found in the Sagittarius constellation in the sky, and it is actually a very bright source of radio light. Yes, that's the same radio your parents or grandparents might have used. So let's look at the options. It is a high energy radio source. Another name for North Star? No. Black hole at the center of the Milky Way galaxy? Not really. In subdivision of a star sign? No. I see where they went wrong. It's a common misconception. Sagittarius A actually refers to the high energy radio source at the center of a galaxy. Now it just so happens that very recently, only a couple of decades ago, we discovered there's also a black hole over there that is the cause of the entire radio emission. But the black hole itself is called Sagittarius A star and not Sagittarius A as given in the question. So out of the options, the most appropriate one is B, although even C is technically true. But I think I'm going to go with B. Let's check the answer. Okay, so the answer is B. It's a radio source anchored in a black hole within a galaxy. That's fair, but it is not the black hole itself. So let's look at the next one. Why is it warmer in summer? Option A, we are closer to the sun. That's actually opposite of what's true. So most of my viewers are probably in the US or India or the UK. We're in the northern hemisphere, so summer for us is sometime in June, and that is the time we're actually the farthest away from the sun, not closer to the sun. And also the northern and the southern hemisphere have opposite seasons, but they're on the same planet Earth, so they both have to be close to the sun or away from the sun at the same time. So that option breaks down right away. Option B, Mars is orbiting close to us and radiating heat. Okay, full points for creativity, but no, Mars is nowhere hot enough to make it warmer in summers. Venus is quite hot though. Option C, the Earth's tilt allows for more heat from the sun. That is actually true, like I explained at the beginning of the video. So going on to the next one, why do astronauts wear white spacesuits? Well, it is a neutral color, but I don't think that's why they do it. Option B, to easily see each other. I can see why seeing each other could be an important thing, but I think a more appropriate answer is option C, the white reflective fabric deflects heat. Let's just check the answer. So yeah, white reflects the most heat and radiation from the sun. This is option C. So the next one, what is the Fermi paradox? This is a good one. So Enrico Fermi was this legendary physicist who was great at estimations. So we asked a question, what is the probability that we'll be contacted by aliens? So you have to factor in the likelihood that aliens exist, then you have to factor in the likelihood that aliens are intelligent, and finally you have to factor in whether the aliens are close enough to us to communicate. But the thing is, given the current laws of physics, almost every scientist thinks that we should have already been contacted by aliens. And yet for some reason we feel like we've heard nothing. And there are a lot of beautiful consequences of this seeming paradox. I'll probably do an entire video on the Fermi paradox sometime soon. But the answer is option A, a question about the existence of aliens. Let's move on. So the final question is, are the constellations the same for the north and the south hemisphere? Okay, so the final question is a very tricky one. So think about it. If you stand on the north pole, you'll basically only see the north of the sky. And if you stand on the south pole, you'll only see the south of the sky. But they have not said north pole or the south pole. They have said the northern hemisphere or the southern hemisphere. So in theory, you could go to the equator, stand 1 meter to the north of the equator and 1 meter to the south of the equator. And for all practical purposes, the sky you'll see will pretty much be the same. And so the answer is definitely not B. Each hemisphere definitely has its own set of constellations, but you may see the same constellation from both the hemispheres. Now option A, will they be in different parts of the sky? I don't think so. The constellations to the north will always be to the north of the sky, and the constellations to the south will always be to the south of the sky. So I think the answer has to be C. Yes, stars are the same from everywhere you look. Let's just see whether we got the last one right or not. Okay, so the answer that they've given is option A. I'm not entirely sure what to make of it, but well, I guess that's all there is from my side. I hope you enjoyed this and learned something as well. Let me know in the comments if I should do more videos of this type, and I'll see you in the next one.